Hello students, this is a video on modeling with linear functions. It's from Common Core Algebra 1. We just did a unit on linear functions, that was unit 7. So if you need assistance with that, I'm here to help. We're going to take a look at a couple of sample problems, and we're going to try to work through some of the difficulties you might have had. So I'm going to give you the problem and then pause the video so you can take a look at it. In this first problem, called the bathtub problem, it's giving you information about pulling a plug out of the bathtub. This may seem familiar to you a little bit. After 40 seconds, there are 13 gallons of water left. 1 minute after you pull the plug, there are 10 gallons left. Assume that the number of gallons varies linearly with the time since the plug was pulled. Your first job is to write the particular equation expressing the number of gallons G left in the tub in terms of the number of seconds S since you pulled the plug. I'll let you pause the video and try to write out an equation for this. Alright, as you can see, I did a little annotation. It says after 40 seconds there are 13 gallons. 1 minute after there are 10 gallons. So these two pieces of information are really ordered pairs. They're partnering 40 seconds, which is your input value, with 13 gallons, which is your output value. And similarly, 1 minute, which is 60 seconds, is your input. 10 gallons is your output. Looks like we're decreasing the amount of water we had in this bathtub. It then asks us to write the particular equation. I circled that. It tells us gallons G, that's the output, and seconds S, that's the input. There's a good amount of work here. I want to walk you through it. The first thing I did was wrote down y equals mx plus b. That's the equation of a linear function. We knew it was a linear function with linearly. We needed to find the slope, so we were able to use the slope formula, y2 minus y1 over x2 minus x1. And we used the points that they gave us. In any of these problems, they're going to give you enough information to find either the slope, which is in this case what they gave you, or the y-intercept, and we'll see that in a future problem. So we calculated that slope, that's in red, and we substituted that slope into our equation, into our function here. That's negative 3 over 20. That can't be simplified into an easier function, unfortunately. Then we found the y-intercept by using y equals mx plus b. We substituted in that slope, and we also substituted in one of the points. We used 60, 10. This is the x value, the input, and this is the y value, the output. We could have used 40, 13. We could have put 13 here and 40 here, but I chose 10 and 60 because they're nice even round numbers. So we solved for b. We got negative 9 here, and we added the negative 9. We added a 9 to both sides to eliminate. We got 19 is equal to b. So this is our function. G of s, that's basically y, equals negative 3 over 20 s plus 19. Here's our slope in red. Here's our y-intercept in green. The next part of the problem asks us to use that function in certain ways. So I'll slide this down a little bit. It asks us how many gallons would be left after 20 seconds and after 50 seconds. And it also asks us at what time will there be 7 gallons left in the tub. I'll let you pause the video now and try to figure those out, and I'll come back with answers in a moment. All right, you can see that I did a little annotation here. It asks us how many gallons will be left after 20 seconds and 50 seconds. And over here it asks us after what amount of time will there be 7 gallons. So it's giving us two different things. Here it's giving us two inputs, and here it's actually giving us an output and trying to determine the input. So you can see the work that I did on both sides, both in red and in blue. On this blue side, I have 20 seconds as my input, one of them anyway. So I took 20 seconds and I inputted it for s. So you notice I wrote down the original function. I turned negative 3 over 20 into a fraction that looks like this because it's easier for me to write. Sorry, folks. G of 20, we call this G of 20, was equal to negative 3 over 20 times 20 because that s was replaced with a 20. You'll see on the other side that s was replaced with a 50 because we're using a different input. And we're just using the inputs that it asks us to use. If it asked how many gallons were left after 100 seconds, this number would be 100. I did a little math here, and I found this was negative 3 plus 19. This whole piece just became negative 3. And then I got G of 20 is equal to 16. Or in other words, there are 16 gallons left after 20 seconds. Same thing over here. I did a little math. I found that negative 3 over 20 times 50 is equal to negative 7.5. And I'll prove it to you here. I know that that is a little bit of a complicated calculation. If I wanted to do this in my calculator, I would say negative 3 over 20 right? That's going to be my fraction. It's going to be inside parentheses. I'm multiplying that by 50, and I should be able to get negative 7.5. As an output, I got negative 11.5. For letter C, I did something a little bit different. 7 gallons was my output, so I substituted G of S, that whole entire piece, with 7. And then I got negative 3 over 20 times S. Remember, we don't know what S is. We're looking for at what time. So I guess realistically, we should underline at what time. And it should be in red because that's the color we're using. So I got 7 is equal to negative 3 over 20 times S plus 19. I subtracted 19 from both sides, and I got negative 12 equals negative 3 over 20 times S. And now I'll show you this calculation. I have to divide by the coefficient of S. So I have to divide both sides by negative 3 over 20. So what I'm doing is I'm taking negative 12, which is this number here, and I'm dividing it by, because I have to do the inverse operation, dividing by this whole coefficient. So I'm dividing by negative 3 over 20. I'm treating negative 3 over 20, that fraction, as one whole number. I'm putting it inside those parentheses. And when I do that division, I get 80, positive 80, which means there will be 7 gallons left in the tub after 80 seconds. Hopefully that made a little bit of sense. Next, I'm going to ask you 2 more questions. It asks for finding the y-intercept and the x-intercept. What do these numbers represent in the real world? You should have a good amount of information about this problem. Pause the video and then we'll take a look at it in a few moments. All right, you can see that I annotated here. The y-intercept is looking for a specific time, and the x-intercept is also looking for a specific time. You should remember that finding the y-intercept is where x is equal to 0, and finding the x-intercept is where y is equal to 0. I wrote those as little notes here. It says that the y-intercept is where input is equal to 0, and the x-intercept is where the output is equal to 0. You can see that I took the s variable and replaced it with 0. So negative 3 over 20 times 0 is just 0, plus 19 is 19. What does the number represent in the real world? The tub starts draining at 19 gallons, or in other words, this is how full it was at the beginning of the draining procedure. And then find the x-intercept. That is where output is equal to 0. We replaced all of G sub S, or G parentheses S, with 0. Then we solved. I'm going to show you that calculation here again because I understand that that might be a little complex. I subtracted 19 from both sides, so I got negative 19 equals negative 3 over 20 times S. Now I'm going to take negative 19, and I'm going to perform the opposite operation of multiply by negative 3 over 20, which is divide by negative 3 over 20. And that should give us 126.6 repeating. This is not an error. That's the answer. It says the tub is empty between 126 and 127 seconds. You don't have to get too much more realistic than that. I'm going to show you one more problem and then I will sign off. Alright, this linear function modeling problem involves shoe sizes. It says the size of a shoe a person needs varies linearly with the length of his or her foot. The smallest adult shoe size is size 5 and fits a 9-inch long foot. 11-inch long foot takes a size 11 shoe. We're supposed to write an equation representing shoe size in terms of foot length. Now remember the previous problem, we were given 2 points and we were asked to find the equation, so you can do the same thing here. Take a moment to pause the video and then I will show you how to do it. Alright, you can see my annotation step here. This I want to speak about briefly because it does say size 5 and fits a 9-inch long foot, and this says 11, but I reversed the order here. I want to explain to you why that is. Remember that the first number is supposed to be the input, and the second number is supposed to be the output. Output, right? Hilarious. Output. So in this case, we're inputting into our equation how long the foot is, and it's supposed to be giving us, it's supposed to be outputting the size of the shoe. It even says here we're supposed to be expressing shoe size, so the first thing that's given, that shoe size is supposed to be the output in terms of foot length. When it says in terms of, that means that this variable is going to be the input. So everything about this problem is telling me that the input value is supposed to be the foot length, that's 9 inches in this case, and the output is supposed to be shoe size, in this case that's 5. And in this one it's a little bit easier because both numbers are 11, so it doesn't really matter which order we put it in, does it? We're supposed to write the particular equation, so I have a couple of pieces of information to find. I need to find the, it's linear, so I need to find the slope and the y-intercept. First, I find the slope, that's in red. That's 6 over 2, which is equal to 3. We used the y2 minus y1. We used this y value, which is 11, and this y value, which is 5. Then we used this x value, which is 11, and this x value, which is 9. We subtracted the 2. We got 6 divided by 2, which is 3. Then we used, in blue here, we used the linear function to find the y-intercept. We knew that 11 was one of the points. We knew that the slope was 3, and we substituted both those in to find the y-intercept. In green, we substituted everything for what it's supposed to be. We're not using y here. We're using an output, which is s. The input value is L. So 3 times L minus 22 is going to be our linear function. That's the equation that we're looking for. Next, our job is to answer these two questions. If your foot is 1 foot long, what size do you need? And Bob Lanier, which I believe is the correct pronunciation, who once played in the NBA, wears a size 22. How long is his foot? Pause the video and I'll come back with a couple of answers for you in a moment. Alright, I did a little annotation. It says if your foot is a foot long, which is 12 inches, what size do you need? I wrote down the function and I took that 12 inches, which is my input, and I substituted in for L. I also substituted on this side. Now notice S parentheses 12 doesn't mean multiply, it just means what is the output when the input is 12. Substituting that number, then we simplify. 12 times 3 is 36. 36 minus 22 is going to give us 14. So if your foot is a foot long, what size do you need? You need a size 14 shoe. Next, here's a picture of Bob Lanier, the man himself. He once played in the NBA. He's a size 22. So what we did was we took that S of L and we replaced it with 22. We have a 22 on this side as well, so don't get confused. All we have to do is add 22 to both sides. We get 44 equals 3L. And notice that we didn't finish this up because you're going to get a decimal. I wanted to walk you through that calculation. We have 44 divided by 3, and we're getting a decimal that looks like this. Just remember that 0.6666667 on the calculator, that just indicates 2/3. So our answer here should be 14 2/3 inches is equal to the foot length. Quite a long foot. Next, find the shoe size rate intercept. What does that tell you about the real world? And also calculate the foot length intercept. What does that number tell you in the real world? Go ahead and pause the video, and I'll be back in a moment. All right, notice I annotated the problems. It asks for the shoe size rate intercept and the foot length intercept. Shoe size rate, that is our output value. So we're looking at the y-intercept. Well, you know the y-intercept is where x equals 0. So we substituted x, or in this case L, for 0, and we got S of 0 is equal to 22, or negative 22. What does that mean in the real world? Well, it indicates to us that if we input in 0 for the foot length, we'll get negative 22 as our shoe size. If our foot length is 0, our shoe size is negative 22, which doesn't seem to make too much sense. This is a mathematical model, and it doesn't really make a whole lot of sense in the real world in this case. Next, it says to calculate the foot length intercept. That is how long of a foot is going to be. I'm sorry, the foot length intercept is what size the foot will be if it is a shoe size of 0. So we can see here that 7 1/3 is equal to L, which means, of course, that a shoe size of 0 will result in a foot length of 7.3 repeating. So this was a discussion of modeling with linear functions from Common Core Algebra 1. Hopefully you found this helpful. Good luck studying.